Welcome back to our series on building a linear regression model in Python with sklearn. In our last video, we did a little further exploration of our data set. What did we do? Well, we created a nice little scatter plot. We measured the correlation. Did a statistical summary and kind of explained what this was. We talked about kurtosis, which basically kurtosis is measuring how pointy our distribution is. So if it's, basically if it's really, you got a lot of kurtosis, it's going to be very pointy and stuff like that. We talked about skewness, which is basically, is it more skewed to the positive values or in the negative values, things along that situation. And then we also did a kurtosis and a skew test right here. So just explaining the results of those tests and keeping in mind that as you get more data, the likelihood that there is kurtosis or skew increases. And then on top of that, basically what it's not telling you is it's not telling you the magnitude of that skew or kurtosis. So with that being said, let's actually go and build our model. And really what we're doing is we're just fitting the data to our model and everything along that nature. So what we have to do is we have to define our input variable and our output variable. In this case, our output variable, or really at this point, our output variable is the price of, it's basically the Exxon Mobil price. That's what we're trying to predict. And so what we'll do is we'll take our price data frame, we'll call the drop method, and then we'll drop the oil price column. And then what we'll do is we have to specify the axis along which we want to drop it. In this case, it's 1, so we want to drop the column. And again, all this is doing is it's taking our data frame, it's dropping the oil price column, so that way we only have the Exxon Mobil series. And that's going to be our output variable. And then our X variable will be the oil price. Now, technically what we can do is we don't have to call the drop method. We can just do double brackets and then select the column. But I like to do different types of examples just so you guys can see there are multiple ways to do the same thing. And so now we have our input variable and our output variable. Now what we need to do is we need to split our data set into a training instance and a testing instance. The training instance is what we're going to use to train our model. And then the testing instance is what we're going to use to basically test it and see how well it's performing. And then after we get those results, we can verify and say, well, is it doing well? Is it not doing well? Things along that nature. Now, to split the data set, it's convention just to do X train. So capital X, test, lowercase y train, and then lowercase y test. And we're going to call the train test split method. This is coming from our sklearn library. So in the first video where I imported it, I imported the test train split method. And then from here, we just need to pass through our input variable, our y variable, and then we have to specify a test size. And convention, usually it's like 20 to 30%. So what I'm saying is, hey, save 20% of the data for testing purposes, and then random state 1. So this way we can use the same random state if we want. And so we'll run this. We now have all of our data split. And so now we can create an instance of our linear regression model object. And so we will give it a very unique name, regression model. And what we'll do is we'll set this equal to an instance of the linear regression object. And then what we'll do is we will fit the data to the model. And so we'll pass through the X train and the Y train. And just like that, what will happen is we get this little output. And so now we just have a regression model. It's been trained in a sense, and we fit the data to the model. And now we need to basically explore the output. So, what did it send back to us? Well, if you remember in the first video up here, Well, we know that a linear regression model is simply a line formula. And so I'd really like to know what my intercept is and what my coefficient is for my input variable. And so we can access that information from our model relatively easily. We'll create a new variable called intercept that will equal our regression model object. We will call the intercept property and its underscore, and then that returns back an array. And then what we'll do is we're going to get the first instance of it. And then what we'll do is we'll get our coefficient. And again, it's the regression underscore model. This time it's the coefficient property, and then it's a nested list. And then what I like to do is we always like to print it out. So print string the coefficient for our model is, and then bracket :2 dot format, and then it's the coefficient parameter, and then I'll just copy this for time, and we'll put this as the intercept, and then this will be our intercept value. So this one's a little bit off sometimes. This, I know why, because I didn't put this as a 4. So disregard these notes down here. Every time I train an instance, it's going to be a little bit different. But basically what it's telling me is my beta 1 is 0.23, and then my beta 0 is 70.55. So this is my intercept, and then this is my particular coefficient. So really at this point we have all the pieces we need to now build a line in a sense, but this is how we access those different outputs from our model. So if you wanted to, you could use this information to manually compute a prediction, or if you wanted to, there's an easier way to do it. So to take a single prediction, it's really straightforward. We'll store our prediction in a new variable called prediction, and then we'll call our regression model, and then we'll call the predict method. And then what this is going to need is basically an array within an array, and then we'll just pass through some random value, 67.33, and then the predicted value is nested in this, so it's nested in the prediction. Hopefully I spelled that right. 0, bracket 0, and then what we can do is we can say print the predicted value is bracket :4, and then format predicted value. And so what is this telling us? Well, if I pass through an oil price of 67.33, I'm predicting that my value of a price of share of ExxonMobil would be $86. So we can take a prediction, but really at some point we're going to have to evaluate our model and see, can we say with a certain level of confidence that, hey, this model works to the degree that we were expecting it. And so what we'll do next is we'll actually do multiple predictions, and then we'll go on to the next video. So to get multiple predictions, we'll create a new variable. This time we'll call it yPredict. We'll call our regression model. We'll call the predict method again. But in this situation, I actually want to pass through my X-test data set. So we're going to use this to, at some point, evaluate our model. And so once we get this, what we'll do is we'll just print out the first 5 predictions, because there will be a lot of predictions. And so I just want the first 5. But as you can tell, it does return back an array, more importantly, an array within an array. And so these were the first 5 predictions for the given oil prices that were part of our X test. So that's all it's doing, is I'm passing through all my oil prices, and these are the predicted values that it's expecting for the share of ExxonMobil. So basically the predicted price of a share of ExxonMobil stock. Okay, so with that being said, I am going to finish the video here. If you have any questions about how to basically build the model or train, fit the data to the model, creating a trading and a testing instance, grabbing the output or making predictions, please put them down in the comments below. In our next video, we're going to actually evaluate our model to see how well it performed to the data. So definitely an important step. You don't want to skip that step, obviously. And you want to make sure that your model is actually doing what you were expecting it to do. So thanks again for watching, guys. We'll see you in the next video.